All right, so this is going to be a crash course in how to set up and run the CESM model. This is just an introductory tutorial. There's a lot more documentation out there. And specifically, what I'm saying is going to apply to the 1.0 version CESM, including 1.04, which is where WACCM-X was introduced. There are some minor changes that are to what I'm saying that are going to occur in version 1.1, which is going to come in November. And I'll point those out when I get to the relevant parts of the talk. I'm just going to give a brief overview of where to find more resources, what you need on a particular system to set up CESM, and then we're going to get into two sort of parts of the workflow, one specific to setting up on a new machine, and then more day-to-day setting up and running a particular experiment, and then talk about some of the other sort of support lines and other resources at the end. So this is just a slightly blurry snapshot of the CESM release page. The two things I really want to point out are the user's guide, let's see, which is going to contain most of the documentation that you'd want to get, sort of the next step to go after what I talk about in this presentation. And the other thing I want to point out here is how to acquire the code. This is the registration link for being able to get a copy of the CESM source code. So here's the requirements for setting up on a new system. Firstly, you need the Subversion client. Both our source code and input data sets are located in Subversion repositories, so that's necessary to check them out. You'll need Fortran C compilers. This is the one requirement that is generally not going to be free. You can use G-Fortran, but we don't focus from a performance perspective on free compilers like GCC. So PGI, Intel, and IBM are used on the systems that we do most of our testing and performance work on. We need a recent version of the NetCDF library. You need some MPI implementation, and most of the major ones work fine. And these are the machines that we've already ported to that are most commonly used. There are a few other examples. Let's get into the one-time steps for getting CESM. The registration page from the link I showed earlier is going to look something like this. I think the form is fairly straightforward. When you fill it out, we'll send you a username and password for the Subversion repository. If you try checking out the code for the first time with Subversion, this is just an example Subversion command. Just accept the certificate, and it's right there at the top level. And once you use Subversion to check out the source code, this is what you're going to get. Within the top level directory of the package we have, you'll have a model directory and a scripts directory. And if you're trying to just get directly to using the model for the first time, the thing you're really going to care about is the create new case script in the scripts directory. The models directory contains more specific build information and all the source code for the individual components. So if you look in there, you'll see these first 5 subdirectories, ATM land, ocean, ice, and glacier. Those are the 5 science components of CESM. Then we have a driver that ties them together in some shared code. If you look in one of the folders for one of the science components, you'll see a bunch of different options. So this is the ocean broken out, for example. So POP2 is our active ocean. D-ocean is a data ocean. It's prescribed rather than a prognostic model. And then there's X-ocean and S-ocean are sort of dead and stub models. And then if you look even farther down, you get directories with built-in source and code information. We also package with CESM some external dependencies that we use. So in the utils directory, you have the model coupling toolkit, PIO, and not shown here is ESMF. One thing to take note of is that you don't actually need these libraries on your system beforehand. They can be built with the CESM model, and we ship their source code with CESM. When you have the source code, the other main thing that you need on your system is going to be input data directory. This is going to contain all the input data sets you need to run the model. It already exists on machines that we support. On new machines, you're going to create it in some publicly accessible place so that every user who's using CSM can use it from the same area, just to save disk space. And actually, when you create an input data directory, you just want to create an empty directory. Because we have CESM scripts that populate the directory for you. When you run a specific case, the CESM actually figures out which input data files you need, and it looks for them here. And if it's not, if they aren't present here, it will use Subversion to actually download that data for you. So that leads to an important point, which is that you don't want to download your input data manually. In particular, you don't want to just check out the root directory of the input data from our repository, because there's a lot of data files there. It'll take a long time. It'll use a lot of disk space. You can run into all kinds of problems, and most of these files are not going to be used for most cases. The specific script that downloads data is called check input data. I'll talk a little bit more about that later, but it creates all the subdirectories of the input data tree, and it checks out the particular files you need for a particular experiment. Again, don't download the data manually, because we've had a lot of incidences of this, and it really, it's much simpler to just let the scripts do it for you rather than trying to check out multiple terabytes of input data. So here's an overview of the directories you might have on your system. You have the CESM source code somewhere, and you have an input data directory. These are actually the only CSM-specific directories you'll have in your system. We don't have sort of pre-built binaries for the libraries or anything like that. The source code for the particular version you're using, and just a convention someplace that users of that system find input data. And so one other thing, the biggest step actually, and running on a new machine is porting. I'm not going to talk too much about it because it's kind of a complicated procedure. The user's guide is a good place to look for information about what different considerations go into that. One thing you really want to do is don't try WACCM-X if you're porting to a new machine as your first run of CESM. Try just a basic CAM configuration, the simplest thing that you could do, because it's much easier sort of from a support and troubleshooting perspective to try to validate a port of the simplest configuration you can find, rather than diving into WACCM-X with all its additional features and performance considerations. Again, on supported machines, you don't have to do this because it's already been done. On new machines, how easy this is really depends on whether we've already ported to a machine like yours. It's kind of an unpredictable process because we don't know all the hardware that's out there. But we have several very sort of generic starting places. And again, the user's guide is a good spot to look for more information. So now I'm going to talk about, from more of a user's perspective, you want to set up and run an experiment, what do you do? So these commands are actually all you need to do to get the model running. And so what I'm going to do is I'm going to go through these main 5 and talk about what goes on at each of these stages when you're building and running the model. So first, we'll talk about creating a new case. By case, by the way, we mean a particular experiment. It's also a particular build of the model, and it has a particular directory where the relevant configuration files are stored. So when we say case, we're talking about all of those things together. There's a particular experiment you're running. This is the command from the earlier page that does the creation of the case. So the command that's being used is in the scripts directory in CESM. It's this one pointed out in red. These are mostly shell scripts in Perl. And this is always the first step you're going to use. So if you type in create new case -help, it explains what all the options are. It looks like a really long list, but actually these 4 are almost always the only ones you need. And they're also required every time. So I'm going to really focus on these. The first one is going to be case, which is just the location of the case directory where you want to put all the information about this experiment. The res is basically the grid that you want to run on. And the format for specifying a grid is to specify the grid for the atmosphere and the land components, and then one for the ocean and the sea ice. Generally speaking, with the WACCM-X case, you're not going to want to bother with an active ocean. And so generally these 2 will be the same, just letting the ocean take its cue from the atmosphere. And each of these possible settings, so F19G16 is sort of a 1 degree comp set. So this is the ATM land, this is the ocean ice resolution. And there's a short name and a long name. And that's simply so that you can have, save yourself typing here. But these are completely equivalent. So if you see these 2, there's no difference between them at all. The third thing you specify is the component set. Right now for WACCM-X, our only supported comp set is FWX. That's likely to change, and there are other component sets under development. This specifies sort of the basic set of options. In particular, it says which components are active and which forcing files are being used. And again, there's short and long names for each component. And then you specify what machine you're running on. Oh yes, that's right. So basically, there's all of our supported machines you can just specify in the command line. Then we have some generic options for particular types of machines that you can use when porting. And in order to find out what actual options you can pass in, what grids, what comp sets, what machines are available, you can use the -list option. And whatever variables you specify here, you won't be able to modify later with this case. So if you need to change one of these things, you're going to have to create a new case. That's almost anything else about the model can be changed after this step. This is sort of the only thing that's locked down right at the beginning. If you type create new case list, you'll see output that looks something like this. This is truncated, each of these 3 sections. It's much longer, but you see it'll just give, the grids are pretty straightforward. Comp sets have a short description with each of them. These are the long and short names. And then the machine, it just gives basic information about what it assumes. So I want to talk a little bit more about what I mean by component sets. the idea is that you have a hub and spoke model where you have a coupler that is allowing interfacing between the different components. And then you have different specific science components for the atmosphere, the land, the ocean, the sea ice. So if you see a B comp set, all of those science models are turned on. G comp sets have only active ocean, I is only active land, and F is active land and active CAM. The FWX comp set and probably all of the comp sets in the works for WACCM-X are F comp sets. So that means it's pretty much just the land and the atmosphere that have active components. And then there are these prescribed data models being used in the ocean and the sea ice. So if you type create new case, it'll give you output that looks something like this. This warning message just tells you which configurations we've scientifically validated. These are ones that we've tested beforehand and actually looked at the output and know that there's some validity to these cases. We support functionality for all kinds of other cases. You don't have to use the same grid here for the vast majority of these cases. But you should just be aware that you might be the first person to try that particular configuration. The combinatorics are pretty huge. There are a lot of grids. There are a lot of comp sets. So we point out the ones that we've already tried. Again, from the WACCM-X perspective, for now, there's only one, which is the WACCM-X 2000 comp set. And then after that, create new case will just tell you some of the things you already put in, component set, what directory it's doing everything in, and it'll tell you if it succeeded, which is a theme throughout all of our scripts. They tell you if whatever they were supposed to do actually succeeded, so you don't have to be left wondering if it got caught off with some hidden error in the middle. So when you've created a new case, here's the directories that you're going to have on your system. Besides the source code and the input data, you'll have created a case directory, which will be populated with a few things. So here's a quick, just an LS of what's in the case directory when it's created. There's a folder that's specific to any modifications of the source code you might want to use in that particular case. The configure script I point out because that's what we're going to be talking about next. And these env files basically are XML files that contain lists of environment variables that control the configuration, build, and run of the model. And then XML change is a script that we have to safely change the values of variables in these files. So here's a section of env run, which is one of the ones that's a user might change most often. You almost always want to change some of these specific options, like how long you're going to run the model for, basically is what's right there. And so above each of them, there's just a XML comment that gives a description of what they are. There's an ID, which is the name of the environment variable, and then there's an actual value. The safest way to change these values is to use XML change to tell it what file you're using, what variable you want to change, and the new value you want to give it. You can edit these XML files by hand. Just make sure that you don't introduce any formatting errors that make it impossible to parse. And here's a quick description of what's in each of these XML files. So env case contains everything that's said at the beginning of the case. Env comp specifies information a bit more detail about the configuration of the particular components. Env mock BEs is basically about the processor layout, how many processors you're going to use, which components you want to run concurrently. This is entirely about performance. It shouldn't affect the scientific results that you get at all. And here's actually a quick snippet of it. So you can just tell it how many MPI tasks to use, how many threads per task, because we do use a hybrid MPI, OpenMP parallelization. And then root P is used to control the layout of processors, of components on processors. env build specifies information about the build. You rarely have to change it. There's makefile specific compilation, machine specific information, which are mainly changed during porting. And then env run is where you set things like the actual length of time that you want the model to run for. So now I'm going to talk about how you configure the case. That's the second of our 5 steps, just this simple line here. And this is one of the things that's automatically in your case directory right after you create the case. These 2 XML files, env-conf and env-mockps, their values are used in the configure steps. So these are the things that these are the files that will be locked after you configure. If you want to change something in a case after the configure step, that's in one of these files. You have to undo the configure and then reconfigure the case. If you type configure-help, it'll give you just a quick list of the options. Configure case does the actual configuration step. Clean all undoes everything that configure-case does, and it saves copies of what was created the first time you configured. And configure clean mock is specific to env mock PEs. So if you want to change the processor layout and nothing else, that's what you use. By the way, after cleaning any of those, you have to run configure-case again to have your tweaks go into effect. Here's the output of it. There are basically 3 sections. First, it generates files in a build-conf directory in preparation for building the model. Then it creates the scripts that are going to be used to build and run the model. And then it tells you that everything worked okay. So your case directory after that is going to look like this. You're going to have a build-conf directory that has more information for the build step. If you do ls on your case directory, these are the new things that are going to show up. These scripts do all the building, running, and the long-term archiving for the model. And build-conf contains something that looks like this. There's a lot of stuff going on here, but if you look just at the CAM-specific files, there's basically a script to build CAM, one to build the name list for CAM, and then a list of input data files. So now, at this point, you're ready to build the executable. That's this step in the quick start guide. And the name of the script depends on the case and the name of your case and the machine that you're running on. So it'll be different every time, but it should be fairly obvious which script it is, because it's the only one that ends in .build. Just as configure locks env-conf and env mock PEs, using the build script locks env build. So any settings you want to change there have to be done before building. If you modify any source code, you also have to rebuild the model. If you want to redo the build from scratch, you have to run the clean build script. That's not necessary for every change, but if you reconfigure the model, the configuration settings change, then you generally will have to clean the build and start build again from scratch. Also, if you change anything in the build system or in env build, it's usually safer. But you don't have to clean build if you're rebuilding and you've just tweaked a couple of source files. It'll automatically detect that you changed those files. Just a basic make situation. The other thing that the build script does is it checks for missing input data. So if it sees that in the case that you've configured, there are certain input data files that are missing, it'll abort and tell you which ones. And if you run the check input data script, which is going to be in our case directory, the -export option will pull those files in and put them in the input data root directory. So once you've done that, it should be the case that all the data that you need is present on the system. If this is the first time you've ever run CSM, obviously all your new input data is going to need to be pulled in. But once you run check input data -export, that should be bring in everything that you need to run your first case. Yeah?
Any idea how long that would take? Like, to pull down a minimal data set the first time you wanted to get this going? Are you talking hours or hours?
No, it'll probably take a few minutes. I mean, obviously it depends on the bandwidth that you've got, but it depends obviously on the specifics of the case and everything, but it's not.
The first time you're running CESM is, say, a very simple CAM configuration.
Yeah.
This is not a long step.
No, generally speaking, the initial conditions files are not that big. So this is just highlighting what the scripts I was just mentioning. So check input data, build options, build, clean to build. So I want to talk briefly about why we have a source mods directory. If you make modifications in the CSM source code that you checked out, every case based on that source code is going to receive those changes. And one reason that that's not desirable is that you may only want to check out the source code once and make a whole bunch of experiments based on it. You may actually have the source code shared between multiple people. You may not even have write access to this directory. It's entirely possible to put this in a public space for people to reference. So generally, any new source code modifications you're going to want to put in source mods. There's a specific subfolder for each component. So if you're changing a CAM file, you're going to need to put it in source.cam. And whatever file you put there will replace the file of the same name in CESM. So what you can do is you can simply copy the original CESM file to that folder, make your changes there, and then when you the next time you build the model, it will use that file instead of the original CESM file, which we think is safer from the perspective of keeping different cases separate. Here I'm just showing a brief showing what you're going to get when you run the build script. So this is the build of the nameless, which is all the runtime options for CESM. This is checking everything in the input data. And then this is the actual compilation and linking of CESM. And this actually might be a longer step than checking out the input data in many cases. It obviously is, again, machine dependent how long this will take. CSM is a large model, so this is not a short build, but it shouldn't take, if it's been going for an hour, then you should probably start worrying. More common to have something like 15 minutes, or if you're lucky, 5. Actually, had timing data on that, and I don't think it made it into the slide. After you've built the model, one thing that'll happen is that you'll have all these subdirectories created in input data, and there's a huge number of different possible files that can go in all of these. But none of the tree has to be set up beforehand. It is done automatically. And then you'll get a run directory, which is where the model is actually going to be run. So each of these subfolders, real quick, these are mostly used during the compilation and building of the model. And this is the directory from which this model will actually be run. If you look inside that directory, you'll see the actual executable, you'll see log files for the build, and you'll see the name lists for each component. These are just basic Fortran name lists that have all the name list settings for each component. So this is a description. This is the part of the quick start guide that has the batch submission for the run script. Usually when you're running the model for the first time or running a specific case for the first time and you want to make sure it's set up correctly, you do an initial run for, our default is 5 days, but usually you can shorten it or lengthen it by changing env run. The other thing you might want to do at this point is actually change component name list settings. And I believe Joe will get into some of the specific settings a little bit more detail, specific to WACCM-X. The run script actually does the same things that the build script does, other than actually building the model. So the name lists will be regenerated, and the input data sets will be checked again. And one of the reasons that the name lists are regenerated is so that you can pull in any changes. These are two ways of changing that work all the way up to 1.04. This is probably one of the more common ways, is to look at this shell script and look at the name list that it's going to write and just modify it by hand. However, as of 1.04, and there's a different way of doing it, which is using a file called user.inlcam that's going to be in your case directory. And again, this is something that Joe's going to talk a little bit more about. But as of 1.1, that'll be the main way of changing settings here. And so instead of having to modify the name list that's present here, you'll simply take whatever options you want and you'll put them in the user.inlcam file in your case directory. And any name list options that you specify there will override whatever CSM would normally put there. If you put in something that would be inconsistent, picking two options that are incompatible, it should simply throw an error and let you know. Otherwise, whatever you specify there will simply replace whatever defaults you would otherwise get. So here's the output that you'll see in several directories. So here's your case directory. Most of the stuff is already present, but once the run is finished, you'll have case docs, which has specifics about how the run, it's basically a backup of sort of the name list settings for your case. You'll have standard error and standard out from the run. There will be logs from the run in the logs folder in the case directory, and then there may be timing data as well. Running the model will also create something called a short-term archiving directory. This can be turned off, but it's on by default, and we recommend you use it. Basically, the purpose of this directory is to move data out of your run directory. It's originally created there, and it's put in the short-term archive once a run is finished up. And the reason for that is that, well, for one, it keeps the run directory cleaner if you're looking for something there, if you're looking at log files. It prevents that data from being overwritten then if something goes wrong with the model or if you're making modifications there. It also gathers the data so that you can use a more permanent archiving solution on it. So all the directories that you're going to have on your system, we have to add a short-term archive. So it'll have folders for each component, and each one is going to have logs and history files. So if you do an initial run and you find that the data is okay, it's doing what you want, it's not crashing, then you want to do a longer continuation run to do your actual experiment. So what you're going to do is you're going to change an env run. You can set continue run to true. And what that will do is the next time the model is run, instead of starting from scratch, it will look for the data produced by a previous run, and it will use that to continue for however long you've told it to run for. And then you just resubmit it the same way as you did the first time. So the two options that you probably want to change at this step are changing continue run and changing stop option so that your model will run for a month at a time rather than 5 days, for example. And you can also turn on auto resubmit. Basically what that does is whatever number, it takes an integer, whatever number you specify there, after it's done, it will resubmit the same job again, continuing from the end. If continue run isn't set true, it will change it to true. And then, and it will continue to do that as many times as you say. So if you want to run 1 month-long jobs and you want to cover a whole year, then you submit a month-long job and you resubmit to 11. And so then when your month-long job is done, it will resubmit again, starting from the output of the previous run. It'll keep going until you've gotten through an entire year. The other thing you might want to do at this stage is turn on long-time archiving to archive the data for you. And one reason to do this is to get it out of your long-term storage, again, in case something is problematic there. It can run in parallel with the run itself. So if when the case I mentioned earlier, where you're running month-long jobs, after the first month, the long-term archive will run and move the data to long-term archive while the next job is actually starting to execute. And because of this, what you can actually do is produce much more data than you have space to regularly store, and it will keep the pipeline going by moving it off-site as you're running. So while short-term archiving is by default on, long-term archive by default is off. So you have to change env run to turn it on. It will automatically submit the L_archive script, which was produced by configure a few steps back. And it can move to, for example, remove from Bluefire to HPSS. And as I said before, it can run in parallel with production jobs. So the overall set of directories you're going to have, you have the input data, you have your source code to create a specific case. That creates a run directory. The run sends it to a short-term archive, and from the short-term archive, it's sent out to some long-term archive solution. So that's sort of covering the basics of how you get through a CESM experiment, just the basics of every step involved. I think Joe and Dan are going to talk more about the specifics of WACCM-X and WACCM, maybe the more interesting scientific details. But this was the basic information about CESM. For more information, which you will probably need, we have on the website specific guides for each model. We also have an overall CESM guide that gets into more detail about what I've talked about here. And that's on our homepage, as I showed earlier. We do have a bulletin board, which might be easier if you're trying to get general assistance, or you might be able to search there and find someone else who had the same problem as you. Our other main support line is, and probably the one that has a faster response time, is our email line, which is mentioned here. We are on the Earth system grid, and I mentioned earlier, our release notes are always also posted on the website. There's also a known problems page, which is probably has a link in about the same place as the release page from the CESM homepage. So that's everything I had, and thanks for listening.
For the recording, can you repeat the question?
Yes, I can. Yeah.
You said that ESMF is distributed with model, right?
Yes, that's correct.
So why do I specify the library when I run the SD configuration and conf?
Okay. He's asking if ESMF is included with the model, why do you have to specify its location? Is your question?
My local machine.
Oh, yes. Yes. I'm not sure I recall off the top of my head. My guess is because sometimes we make it possible to swap it out for an external version. And so that's a way of specifying the external version you want it to use.
It may not be necessary to do that anymore. I think this is for the Gregorian calendar, why you use
I suspect that you're correct, but it may have been a versioning issue in that case, and that's why it's hard to answer off the top of my head. But it may be that it was a different version that we shipped than SD needed for that functionality.
I'm running SD, so that's why.
Okay.
Also, I want to comment that it takes hours to download the initial condition files because I am offsite, so not just 15 minutes.
It's
For the WACCM files will be like, there's a lot more chemistry. You're testing at 4.
Besides NRL and putting it through some kind of brutal filter, checking every course.
So yeah, there's a lot of variables which, different cases need radically different amounts of data sometimes.
So maybe you could say a little bit about batch queuing. Like, so you put
Yes.
dedicated stuff here, but what's the other batches that are supported or queuing systems that people might have?
I know probably outside of Bluefire, almost everybody uses PBS. Oh, sorry. It was about batch queuing. What other batch queuing systems were supported? I know we do PBS systems. I can't, off the top of my head, it seems like most of the other systems use that. bsub is an LSF command, and that's what Bluefire uses. So that was the example in my talk. And one thing that I didn't point out is that you can change the run script to actually change things like the wall clock time you're asking for. And so that's sort of something you want to look at the batch submission documentation really to get information about. But the run script that you get is where you're going to have to change those variables.
Is it possible to have the run finish on 8th day?
That's,
So I want the run finish on March 10th.
Okay.
Is it possible to do that? Or do I have to count the number of days?
The question was whether it's possible to stop the model on a particular date as opposed to specifying a number of days or months. And the answer is yes, you can specify a specific date. This is one of the things that is covered by stop in and stop option in ENV run. And information about all the different environment variables and options there is in the CESM user's guide. Has a fairly comprehensive listing. Is there anything else?